All right, so I'm just recording this video because I want to show you guys how to design the PCB project, which I want everyone to work on. I'm just recording it again. I did a few meetings, but I think it's gonna be easier if I don't have like a crowd of people watching, and I've already done it twice on videos, on like video calls. So I'm just gonna do it alone. So the first step is you're gonna go to 365.altium.com. Oh, let's see, and then if you're not logged in, it's just going to ask you to log in. But if you just log in with the account I gave you that has a license and everything, it should work. I sent you all an invite to join the workspace, which is the Rutgers University -4. Um, and if you just go to your email, you should be able to find it. I sent it to everyone that I give a license to. So now what you're going to do is you're going to go to projects. You're going to find this one that's called TSAL Lite. Go to the bottom right, these three dots, click clone. And then just change it to your name dash TSAL Lite. So I'm gonna make it James underscore Yim underscore TSAL underscore Lite. Then I'm gonna click clone. So pretty much what Altium 365 is kind of like Google Drive for Altium, and it's just in the browser. And what you do is you kind of browse the different designs that are made. You can view them. You can't really edit them from the browser. Let's see. When I click on this, you're kind of going to get an idea of what you can do in this. And before you try to do this, you're going to need Altium installed, because the next part is I'm going to open the project in Altium Designer. Let's see. It's processing the design. So this is the schematic that I made. And I just want you guys to use the schematic. I selected the components and everything for it. The resistor values are correct, and they're all connected to this connector. Let's see, if we go to PCB, you're going to see the PCB that I was starting to design. 3D, you can kind of see it. If you have like a more built up board like this one, hopefully this loads in quick. And then I go to design files and I click, this is the one I was working on. You can get like I guess a nicer 3D file. These 3D files are like the 3D designs for the components don't really matter too much. They're kind of just there for visual representation. But going back to this, now you go to the bottom left, click open project in Altium Designer. It's going to give you a prompt. I click open. Now it's going to launch Altium. This is pretty much just moving it off of the online drive and opening in the software where I can make modifications to it. And like you saw on the last board, in the preview, let's see. While that's loading up, I'll show you guys this. So you can see this is the schematic. By default, it's showing like this board, which obviously isn't complete. It's just on the source documents. You can make kind of different versions of the same schematic, like different PCB designs of the same schematic. So this design and this one are both based off of this schematic, but I just made like a new PCB document within the same project. All right, so here you can see on the left that I have the file open. We have the home page. This is what it's going to look like for you guys when you open it. I'm just going to open up the schematic in my source documents. We can see this TSAL Lite schematic in the PCB. It's here. I'm opening that up right now. This is just the old one. This is the one you cloned over from the file I made before. This is kind of like rubbish for you guys. You don't need it. So I'm just going to do delete file. And then, whoops. I'm going to right click on the project, click add new to project, and do PCB. Now I'm going to rename it to James underscore James. And yeah, I'm just going to leave it at that. This one's also, the naming for this doesn't really matter that much, since it's all under this project. But it is a little bit easier if you kind of keep the names consistent. So the first thing you're gonna notice is you have this black square. That's the board. So if I click 3 on the keyboard, it's gonna show me a 3D view. You can see it's just a PCB. There's nothing on it. It's not interesting. It doesn't even have any of the components. If I click 2 on my keyboard, I'll go back to the default view. 1 is also a different view. So 1, 2, and 3 are all different views. You're gonna do most of your work in the. I don't really know exactly what this view is called. It's probably board view. That's you just get to this if you press 2. So the first thing you're gonna notice is that here we have the origin. So if you place down a component and then you go to properties, it's gonna say like its location. All the locations are just relative to this origin point. You can actually change the origin point if you go to edit and then origin, you can set it. I like to just keep it at the same spot. There's not really a point in changing it. Hold up. Give me 1 second. All right, so now to kind of tie the schematic into the PCB file, you go up to here and you click design and then import changes from James from the project. So it's going to import the schematic files or the schematic into the PCB. So you see all this stuff, you don't really have to look through it. You just click execute changes and it's going to import all the components and the footprints into the file. Something I like to do when I get all these components kind of just laid out like this, I try to get them laid out similar to the schematic, so I know how they're working and I kind of know how they connect. And that helps you set them up so they don't have crazy tracing, crazy distance between the traces. It is a little bit finicky to select each component, but they really just care that you completely select all the components you want. And then the ones that you don't want, like here you can see LED 47 is kind of selected, but not really. Actually, I completely selected 48. Yeah, you see I left out a little bit of LED 25. Oops. If I leave out a little bit of LED 25, it won't select it at all. But if I include a little bit of LED 48, it won't collect it. I mean, it won't select it. So that's useful to know. Just kind of moving everything over. This thing right here, the red I guess box. It's called a room. I'm not really sure exactly what it's used for. I talked to one of the members, Mike, about it because he also was wondering what the purpose of it is. And we kind of came to the conclusion that's not really super commonly used. They call it a room. That's what it's. I mean, that's what it's called in Altium. My understanding is it has more application in like more complex boards, like super complex boards, especially if you allow like a lot of daughter boards. But for our applications, I haven't ever had to use it. Here you can see one of the that's one I think LED 63 for some reason it's not in the same like order exactly as others, but that's not a big deal. It should just be right there. I'm gonna line up my connector there, and as you can see, that's the same thing as this. So up here we have our red LEDs, down here we have our green LEDs. Something that's interesting to note is up here I have a lot more LEDs in series than down here. It's just because of the colors. The different colors have different voltage drops across them. So at least like a slight design change where I have more in series here than down here. If you want to learn more about that, you could look it up. It's not super. Just search for something about like selecting resistor values for LEDs or LEDs in series, and you should be able to read about it. For here, you can see these lines. These are nets, and you can even see them on the labels. They're labeled. So that's just the nodes that they're connected at electrically. It pretty much just draws the nets to the closest point, which is on the same net. That's why this wire is connecting down to these. That's the same thing as this long connection that's connecting down here. All right, so now that I have all those set, I'm gonna start making the board shape. Uh, let's see. Since this is it's gonna be an LED indicator that's mounted under the roll hoop. And we want it to be visible from 360 degrees. I'm going to make it a circle. Whoopsies. Actually, you can see the circle. I drew it on the top layer. I don't really want it to be on the top layer because I don't want it to be made out of copper. So I'm going to switch it to mechanical layer 1. Mechanical layer 1 does not contain, like when you send it to the manufacturer, they're not going to look at mechanical layer 1 and be like, oh, these are copper lines. They're just going to see it as like a mechanical layer, which I don't really know what they define that as, but it's not electrical. You can see here when I clicked on this circle and then I went to properties. Let's see, I think pretty sure you can do that just by double clicking on it. Yeah, it opens up properties. You can see our units are in mil, which is thousandth of an inch. I'm gonna press Q on my Q. Well, when I click out here, I'm gonna press Q on my keyboard. You can actually see down here it changes it to millimeters. I like using metric for the electric subteam, and we've always done that. I'm gonna change this to, let's see, 80 millimeter radius. And then I'm gonna go up here. I'm gonna change this, the center of the circle to, whoopsies, 100 millimeters. And another one, 100 millimeters. And I'm gonna lock the location. And now I'm gonna click on the circle again. I'm gonna go design, board shape, define board shape from selected objects. Since the circle is selected, it's gonna make the board shape out of that. So if I click 3, you can see the 3D view. The board is contained within that 80 millimeter radius circle. All right, so now to put the components on, there's something useful I like to use, which is the grids in Altium. So we go here and click properties, make sure we're not selecting anything. You just want to click down here where you're just kind of selecting the project. You go here, add grid, add polar grid, since it's going to be lights radiating outwards. And then we're going to, so this is our polar grid. Angular step, I'm going to do 8.5 millimeters. This is actually kind of something I did the calculation on earlier because I think it's what, 48 LEDs. Let's see. 360 degrees divided by 48. Okay, so that's 7.5 degrees for the red LEDs. Actually, that's one. So for the red LEDs, it's going to have a 7.5 degree spacing between all of them, rotationally, because there's 48 of them. And then for the green, I think it's going to be around 8.5 degrees since there's 42 of these. Well, the green's going to have 7.5 degrees, red's going to have 8.5 degrees. Just because of the difference in the quantity of them. So I'm going to change this to 8.5. And this is going to be an inner circle of green LEDs. And you can see it's starting to make the polar grid down there. So I'm going to do 0 degrees to 360 degrees. Now I have the polar grid going all around. The radial range, I'll just make it 0 millimeters for now, and then I'll make the maximum 80 millimeters. So we fill the whole board shape, and the origin I'll do 100 millimeters just like I did for the circle. 100 millimeters. And now I have this polar grid that these will all snap onto. So I'm going to start dragging these LEDs on, and I'm going to speed this portion up, I think, for the video. So I'm not going to talk for this. Actually, well, I should probably talk for the first few because it's going to be a little confusing. You can see there when I dragged it, it made the grid disappear. That's because component is not selected on the grid itself. So now I selected it. It's going to guide the placement of these. So now I dragged it out to there. You can see it's not really, right now it might not make sense, but it's not the orientation I want it to be. I'm going to click space twice. And then now you can see negative side's over there, the positive side's over here. You can tell this is negative because there's a dot and the indentation in the circle. It's gonna make more sense when I drag this resistor out here. You just press space to rotate it. That it is now. I'll drag this LED on, and it's gonna make sense why I'm rotating them. So I rotated them so that the nets between them, they're not overlapping too much. You can see the net connects right there. And if I had them rotated, like their default positions was for like that, kind of crossing all over each other. I'm not a fan of that. I want them kind of the pins that are connected to each other to be as close together as possible. All right, so I'm gonna fast forward this video until I get to something that's notable. So you can see here when I picked it up, you see how I picked it up from kind of the center of the pin. You don't really want to do that because then you're not grabbing it from the center of the component, you're really picking up from the pin. So to get past that, you kind of just try clicking on it again, and it should grab it from the center. All right, so another notable part you can see is here, there's this little spacing here. That's since I divided 360 to 360 divided by 40, 42, since this is 8.5 degree spacing. Since it's not actually amounting to 8.5 on the dot, it's like 8.6 almost actually. There is a little bit of spacing that's kind of left over from adding 8.5 degrees. So what you have to do is you just place it on the outside of that, and then on the next one you're gonna put it over here. Oops. All right, so now you can see I have all my resistors laid down, and then they have their little what's it? So you have the resistor, and then you have this little chain of three LEDs that follow it, and then they connect to ground, which is not really ground. That's how we're triggering them, but it's just they connect to pin 3 of the JST connector. Um, and up here, these resistors are all permanently tied to 12 volts, which is pin 1 of the JST. So that's why I kind of keep them these nets going across. They're all connected to the same thing, so it's easier to have them like this. Now that I'm looking at this, I'm seeing that these LEDs, I don't really like how far out they are, because I'm gonna have to put another ring of LEDs around. But that kind of goes back to why I use this grid. It's super easy to move them now. Just drag them down one at a time, and now I have more space. So I'm gonna do this real quick. I'm gonna drag them down too, and I'm gonna fast forward it. All right. So now I'm gonna make my second grid. I'm gonna turn off the first grid I had, so we can't see that anymore. I'm gonna make this 7.5 for the red LEDs since there's more of them. Radial step also make this 5 millimeters. Radial step's just the outward concentric circles for the grid. Whoopsies. Uh, Again, I'm gonna make this 0, this 80. The origin, I'll make it 100. Start angle, end angle, 360. All right, there we have a grid setup. Also, I think something I'm going to change, I mentioned earlier, I'm actually going to move these resistors according to this grid since it's a smaller angle, just because they're going to be in the same kind of spacing as they're going to be like next to these. So it's just going to make the kind of the spacing play better when I have these down. But I'll adjust that after I get these LEDs laid down. So I'm just going to fast forward laying these LEDs down, and then I'll show you guys how I'm going to do the resistors. All right. So now you can see I already put down one of these resistors, but I'm just trying to keep these kind of close to the center, as compact as possible. I'm gonna put them on this polar grid, just because it's a smaller angle. We're gonna be able to space more in. But it's the same principle as others. The spacing, it's really just you kind of just look at how the nets line up. This line that's above this resistor, and you just try to get it as concise as possible. It's not. It's more of kind of. I mean, it's not even like art. It's just you just feel it. It's not anything to go back and change it, but it shouldn't be incredibly difficult to figure it out. It's more just a matter of making it easier for yourself later than getting it like completely correct. So now to put the JST connector in the center, I'm just going to disable the grid. Since we already have everything in it, I'm going to put it in the center here. And we'll set the XY is 100, 100, and there we go. I think that's a little off center because I think the center of this actually should be in the center. I was looking at it earlier, and for some reason it didn't look like it was in the center, but I think this should be right there. Oh, well, should let's see. I don't think it is exactly in the center, and I think that has to do with the way the footprint's laid out. But yeah, see the footprint's actually centered around this bottom pin. Uh, but I think for our purposes, it's fine if it's a little offset. I was thinking in a different version. I think I'm gonna have two JST connectors. Which actually, let's see, for extra credit, you could actually add another JST connector. So copy, paste, place that down, and then draw some wires. And then you go here, but you gotta save this actually before you import changes. Import change, execute changes. Oops, it's not labeled. So you always gotta save changes to the schematic before you can import them. Okay, so now I put a designator name on this. It's J2. Also, you might notice everything here is green. That's because there's error markers on them. It's because it doesn't follow the design rules, which you set up yourself. You just click reset design error markers. It's gonna get rid of it. Now I'm gonna put all of these down. I'm gonna make this, let's see, 102.5. Shall make this 103. I don't know if you guys can hear music in the background. I think one of my roommates is playing music in his room. All right, I'm gonna reset the error markers. There we kind of have our preliminary PCB. Now all that needs to be done is routing. I think for now I'm gonna stop this video, but I'm gonna have it edited together so you can see routing, which I'll do in the next recording.